Hi everyone, I am Edson Luque, a young researcher in LaSalle University of Arequipa in Peru. I will briefly present my work called a novel stochastic model based on equistate network for hydrological time series forecasting. Okay. Motivation. Natural phenomena such as precipitation and stream flow discharge have nonlinear, complex, and chaotic characteristics. For example, in Figure 1, we can see the trends of temperature and precipitation in the USA since 19th. Okay. On the other hand, in probability theory, a stochastic process is defined as a set of models that allow to the study of problems with random components like forecasting hydrometeorological time series. Afterwards were development methods using self-correcting models such as the PR model. However, these models are statistical, linear, and they cannot capture real chaotic characteristics of hydrometeorological time series being something inadequate. Deep learning approach attempts to model this complex nonlinear behavior. Deep learning has been widely used recently from the simplest feed-forward neural network to the most complex recurrent neural network like LSTM. However, literature on a stochastic model shows a preference to use feed-forward neural network than recurrent neural network because the last one generates greater complexity in the training process, slow convergence rate, and vanishing gradient problem. Okay. All this motivates the development of new stochastic process using recurring neural network and the equistates ESM learning mechanics instead of conventional backpropagation. The property of ESN is that only the real-out layer is training because the recurrent topology has physical connection weight. ESM is a training approach that is fast and straightforward compared to the other methods used in recurrent neural network, all to reduce complexity and leverage its proven ability to represent the characteristics of time series. Well, our proposal is called the stochastic stream flow model ESM. Figure 4 details our model. It generates scenarios Y of VT of syntactic hydrological data in terms of monthly intervals and can be resumed by the equation 1. Okay. Where E of VT is the value produced by the recurring neural network with the equistate learning mechanics, equation 2, where W out is the weight matrix between the internal states x of t plus 1 added to the input signal y of t and the output nu. Okay. Finally, sigma is the activation function. R of Vt is the stochastic value, where sigma t plus 1 is the standard deviation of in month t plus 1. The correlation coefficient between months t plus 1 and t is R of t, and a normally distributed random noise with zero mean and standard deviation 1. All above equations are concatenated to obtain the extended equation of our model, represented by this. Okay. About preliminary results, experiments were made using the well-known MOPEX data set. Table 1 shows our model as a promising stochastic model. It outperforms the feed-forward model NSP, LSTM of the shallow statistical model TF in forecasting performance, learning speed, and short-term memory capacity. It may seem surprising that a recurrent neural network with random connection may be effective, but randomizing parameters have been successful in several domains.